In any serious PKI, trust doesn't start with technology. It starts with clear rules and documented practices. The certificate policy, or CP, answers the what question. What level of assurance do these certificates provide? What identities can be issued? Under what conditions are they considered trustworthy? Think of it as the governance blueprint for your digital identities. The Certification Practice Statement, or CPS, answers the how question. How are keys generated and protected? How are identities verified, certificates issued, logged, revoked, and audited in real life? This is where responsibilities and concrete procedures are spelled out. Together, the CP and CPS form the foundation that lets regulators, auditors, and relying parties understand exactly why they should trust a given PKI and the certificates it produces. When we talk about PKI, it's tempting to focus only on keys, certificates, and crypto. But the real foundation of trust is governance, the rules, controls, and evidence that sit underneath the technology. Every certificate a CA issues is backed by legal obligations, security controls, compliance standards, and specific operational procedures. These are captured in policies and practice statements that spell out how identities are verified, how keys are protected, and how incidents are handled. Standards bodies and auditors then check whether those promises are actually being followed. That external oversight is what turns we run a secure CA into trust that can stand up in court, in an audit, or during an incident review. In other words, PKI doesn't just create cryptographic trust. Governance makes that trust legally and operationally defensible. To run a serious PKI, you need both the rules and the real-world actions behind them. The Certificate Policy, or CP, is the high-level rulebook. Think of it as the architect's blueprint. It describes what the PKI is allowed to be used for, what level of assurance is required, and which security and compliance requirements must be met. It's abstract and relatively stable, and usually there's just one CP per PKI. The Certification Practice Statement, or CPS, is where those rules turn into day-to-day behavior. This is the builder's manual. It explains how the CA actually issues, manages, and revokes certificates, how keys are protected, which procedures operators follow, and which controls auditors can verify. A single CP can support multiple CPS documents for different CAs or different assurance levels, but they all have to faithfully implement the same underlying policy. The key point: the CP defines the what and why, while CPS documents prove the how in operational terms. Both must stay consistent, versioned, and publicly accessible to maintain trust. Think of the certificate policy as the law of the land for your PKI. It doesn't talk about specific servers or tools. It defines what certificates are allowed to be used for, who can get them, and under which conditions they're considered trustworthy. First, it sets intended usage. Are certificates for TLS, code signing, or document signing? Can contractors use them, or only employees? This avoids people reusing a certificate for something it was never designed to protect. Next, it sets security expectations. It spells out how identity must be verified, what authentication is required, and what high assurance actually means in your environment. That's what lets you distinguish a quick, low-risk certificate from one that can authorize big financial or production changes. Finally, it serves as a contractual baseline. When an organization subscribes to a CA, the certificate policy is the primary governance reference everyone is bound to. If there's a dispute or an incident, this is the document you go back to and ask, did we follow the rules of our trust framework? When we talk about PKI governance, we're really talking about policies, and RFC 3647 gives us a common structure for those policies. Every policy starts with a clear identity. It has an identifier, a version, and dates, so people and systems know exactly which rules they're following. and whether they're current. Next comes scope and applicability. The policy must state where it applies, which environments it covers, and which relying parties can trust certificates issued under it. This prevents a one-size-fits-all policy from being misused in the wrong context. Then we define administration. Who owns this policy, who can change it, and what approval workflow is required. Without explicit ownership, PKI rules drift, and security weakens over time. Finally, policies must reference the standards and legal frameworks they depend on. That anchors your PKI in external requirements, like industry standards or regulations, and makes it defensible during audits, incidents, or legal scrutiny. You can think of PKI assurance as a mixing board where you tune several sliders to match your business risk. Assurance level decides how much trust you're willing to claim. Are these identities lightly checked or highly verified? Key size represents the cryptographic strength. Larger keys and modern algorithms resist more powerful attackers, but may cost more in performance and hardware. Identity proofing is all about how rigorously you verify who's getting a certificate. Is it self-asserted, document-based, or backed by in-person checks and strong HR data? Risk appetite tells you how aggressive or conservative you should be with all of those settings. A bank or government will push assurance, key size, and proofing higher than a low-risk internal lab system. The certificate policy is the document that locks these choices in. It translates your risk decisions into concrete cryptographic rules, and into what the certificates are allowed to be used for, and what they must never be used for. In PKI, the real gatekeeper isn't the math. It's how strongly we verify identity before issuing a certificate. At the lightest end, domain-validated certificates only prove that someone controls a domain. That check is usually automated and says nothing about which person or organization is behind the site. Extended validation certificates go further. Here, the CA performs rigorous checks on the legal entity, its ownership, and its right to use that name. The goal is to bind a cryptographic key to a real, accountable organization. Underneath, the certificate policy defines which identity proofing methods are allowed. That includes whether the subject is an individual or an organization, whether verification must be face-to-face or can be remote, and how ring keying and revocation are handled over time. All of this determines how much trust you can place in the identity that a certificate represents, beyond just proving control of a key. Now let's turn to the certification practice statement, the operational engine of a certificate authority. The certificate policy sets the high-level rules and promises. The CPS turns those rules into detailed, step-by-step instructions that real people can follow. It tells staff exactly how to verify identities, how to generate and protect keys, how to issue, suspend, and revoke certificates, and how to handle incidents. If the CP says keys must be protected, the CPS spells out which HSMs, which processes, which logs, and which approvals are required. This document also doubles as evidence. Auditors and relying parties use it to check whether the CA's day-to-day behavior actually matches the claims made in the policy. In short, the CP defines what trustworthy should mean, and the CPS proves in operational detail how that trust is delivered and demonstrated. Running an operational PKI is mostly about people, process, and key hygiene. RFC 3647 gives a structured way to describe this. Who is allowed to do what, on which systems, and under which controls? You typically have clear roles: the certification authority that signs, the registration authority that vets identities, security officers who enforce controls, and auditors who independently verify that rules are followed. Those roles sit on top of protected infrastructure. That means strong access control to CA systems network segmentation, logging and monitoring, plus strict physical security around any machine that can touch a signing key. The other pillar is key hygiene across the certificate lifecycle. Keys must be generated with good entropy, stored in HSMs or equivalent secure modules, backed up carefully, rotated when needed, and securely destroyed at end of life. When you combine defined roles, hardened infrastructure, and disciplined key management, you move from "we issue certificates" to "we can prove our trust process is reliable and auditable." To run a trustworthy PKI, technology alone is not enough. You need a stack of controls that work together. Hardware, logical security, and formal compliance. At the hardware layer, the private keys of your certificate authorities should live in certified hardware security modules. Think of FIPS 402 Level 3 as a baseline. It means tamper-resistant devices, strong key protection, and strict handling of any attempt to access or extract keys. On top of that, you add logical controls. Every sensitive PKI action, like issuing a new CA certificate or exporting a key, should require multi-factor authentication, dual control, and separation of duties. No single administrator should be able to compromise the PKI by themselves. Finally, the compliance layer defines the rules and proves that you follow them. Frameworks and audit programs translate high-level standards into concrete technical controls, such as network segmentation, detailed logging, and operational procedures. Auditors then verify that your PKI actually operates according to those rules. When all three layers align, hardware protections, strong access controls, and audited processes, you move from "we hope our CA is secure" on Spanishing entailed using high levels. In a mature PKI, the certificate policy and the certification practice statement can't live in separate worlds. Every requirement written in the CP must have a clear, concrete procedure in the CPS that shows how it is actually done in operations. This one-to-one mapping gives you traceability. No requirement is left hanging with no control behind it. It also gives you auditability. When an auditor asks, "How do you meet this rule?" you can point directly from the policy line to the documented process, logs, and evidence. It also drives change management. If you tighten or relax something in the CP, that should immediately trigger a review and update of the matching CPS procedure. So your documented practices never drift away from your declared policy. Certificate policies and practice statements only create trust if people can see them, track their evolution, and know who approved what. Publication is about transparency. Relying parties, auditors, and even internal teams must be able to look up the current policy and understand the level of assurance behind your certificates. Versioning ensures you never lose the history. When you tighten requirements, introduce new algorithms, or change validation steps, you record that as a new version, instead of silently editing the old one. Notifications close the loop. Any change that affects assurance, like shorter key lifetimes or new identity checks, should trigger alerts to operations, security, and key relying systems, so they can react. Finally, governance is the control layer. A defined board or authority reviews proposed changes, checks them against regulation, risk appetite, and business impact, and only then approves a new version. Together, public access, clear version history, timely notifications, and formal approval keep your PKI predictable, auditable, and trustworthy over many years. Governance documents like the certificate policy and the certification practice statement act as your shield when things go wrong. They don't just exist for auditors. They define how your CA must behave in a way that can be tested, compared, and defended. Because they are written standards, You can benchmark your PKI against industry norms and regulations, instead of arguing about opinions. They also force alignment. Enterprise CAs, business units, and vendors all have to match the same documented rules, so you avoid shadow PKI and one-off exceptions. Most importantly, during an incident or legal dispute, these documents become the reference point. If something breaks or is abused, you quickly check. Did we follow the CPS or did we deviate? That gap analysis drives remediation plans, audit findings, and, if needed, your legal defense. In mature organizations, CP and CPS are not paperwork. They are the operational contract that holds PKI risk management together. Think of your PKI trust as a stack. At the top is strategy, the certificate policy or CP. It defines what you're trying to achieve, who you trust, and why the PKI exists in your organization. Below that is tactics, the certification practice statement or CPS. This is where the how lives, how keys are generated, how identities are verified, who is allowed to operate the CA, and how incidents are handled. When CP and CPS are consistent and aligned, the output is a certificate that relying parties can actually trust, because they know both the intent and the implemented controls behind it. But this isn't set and forget. Threats, regulations, and business requirements change. Continuous audits and periodic reviews are what keep the CP and CPS in sync with reality, close compliance gaps early, and maintain trust over time.